Have you ever really thought about what's going on inside your Java application? I mean, really deep down? It's kind of like a tiny, bustling city in there, and the workers, the ones doing all the heavy lifting, are the threads. So today, we're going to follow one of these workers on its entire journey, from the moment it's born till the second its job is done. And that brings us to the big question, right? It's so easy to think a thread is either working or it's not, on or off. But the truth is way more interesting than that. A thread can be waiting, it can be sleeping, it can just be standing in line for its turn. And getting a handle on these different states, that is absolutely fundamental if you want to write really solid, efficient, multi-threaded code. All right, so here's our game plan. We're going to start right at the beginning with the birth of a thread in its new state. Then we'll see how it gets runnable, how it can take a little break in the waiting state, and finally how it ends its journey and becomes terminated. And at the end, we'll pull it all together with a complete map of the whole lifecycle. Okay, let's kick things off. Every thread has to start somewhere, and for a Java thread, that beginning is called the new state. This is where it's created, but it's not quite alive yet. So what does new really mean? Well, think about it like this. You've written up a to-do list, a perfect set of instructions for a task. But that list is just sitting on your desk. You haven't actually handed it to anyone to start working on it. That's a new thread. It's just an object, taking up a little space in memory, holding all this potential. But the big boss, the operating system's thread scheduler, it has no idea this thread even exists yet. And here's what it looks like in your code. That's it. When your program hits this line, new thread, a new thread object is created, and it's officially in the new state. It's been born, but it's totally dormant, just waiting for the signal to actually get to work. Okay, so we've got this brand new thread, and it's just sitting there doing nothing. That's not very useful, is it? So how do we wake it up? Well, that's where we move it to the runnable state. The magic happens with one simple method call, .start. When you call .start on your thread object, you're basically tapping the Java virtual machine on the shoulder and saying, hey, this worker is ready to go. The JVM then takes your thread and introduces it to the operating system's thread scheduler, putting it in a big pool with all the other threads that are ready and waiting to run. This is the line that kicks it all into gear. Calling .start is what transforms our thread from just a plain old object into a real, active part of your program. It's officially in the game now. Now, this right here is probably one of the most important distinctions to understand. Runnable does not mean running. I'm going to say that again. Runnable does not mean it's running. Think of it like being at the DMV. Being runnable means you've got your ticket and you're sitting in one of those uncomfortable chairs. You're ready, you're waiting. Being running is when they finally call your number and you're up at the counter actually getting your work done. The thread scheduler is the one calling the numbers. But a thread's life isn't just a frantic race to the finish line. Sometimes it has to hit the pause button. It needs to wait for something to happen. And that's where we get into the waiting and blocked states. So a running thread can be put on hold for a few different reasons. You could literally tell it to take a nap for, say, 50 milliseconds using thread.sleep. Or maybe the thread needs a resource, like a file that another thread is currently using. In that case, it's blocks until that resource is free. In either situation, the thread gets moved out of the running state, which is great because it frees up the CPU so another runnable thread can have its turn. Okay, so what happens when the wait is finally over? This is a super important point, and it's a classic interview question. The thread does not just jump straight back to running and cut in front of everyone else. No way. It has to go back to the runnable state. It's back in the waiting room with a ticket, and it has to wait for the scheduler to call its number again. And this is often the signal that wakes a thread up. When another thread calls notify, it's like a little tap on the shoulder. It's telling the waiting thread, hey, that thing you were waiting for, it's ready now. So the thread wakes up and gets right back in the runnable pool. Sooner or later, every thread's job is done. Its story has to come to an end. And when it does, it enters its final state, terminated. This is the best, most natural way for a thread to finish. See, the whole purpose of a thread is to execute the code inside its run method. Once it hits the very last line of code in that method, its work is finished. Mission accomplished. It just gracefully exits and enters the terminated state. Some people even call it the dead state. Now, I know what you're thinking. What if a thread is stuck in a loop, or it's just misbehaving? Why can't I just pull the plug and force it to stop? It's a tempting idea for sure, and there used to be a method to do just that. But you should absolutely never, ever do it. The stop method is deprecated, which is the official Java way of saying this is a terrible idea and will break your application. Why? Because it's just not safe. It's like yanking the power cord on your computer while it's in the middle of saving a file. It doesn't get a chance to clean up after itself. If it was holding a lock on some shared data, that lock might never get released, causing other threads to wait forever. That's a deadlock. It can leave your whole application in a messed up, unstable state. The right way is to always let your threads finish their work and exit naturally. Whew, okay. We've gone through all the individual stages of a thread's life. Now let's take a step back and look at the whole journey on one complete map. And here it is, the whole story in a nutshell. It starts as new when you create it. Then .start makes it runnable. The scheduler chooses it and it becomes running. It might call .sleeping and go into waiting. A .notify call wakes it up and sends it right back to the runnable pool. And finally, when its run method is all done, it becomes terminated. From birth to death, that's the path. So, why did we go through all of this? Because understanding these states isn't just about passing a test. It is the key to debugging those really nasty problems, like deadlocks, and for optimizing your app's performance. When you really get this stuff, you can build powerful concurrent systems that work exactly the way you want them to. The secret life of a thread is now something you can control.